So here we want to solve this equation for x. So we have x minus 1 raised to the power of the common log base 10 of x minus 1, and that's equal to 100 times x minus 1. So the first thing that we can do is take the logs of both sides, and in this case take the common log of both sides, meaning the log base 10. So then we have log of x minus 1 to the power of log of x minus 1 is equal to the log of 100 times x minus 1. Invoking the properties of exponents for logarithms, we can move this expression here out from its exponential position and put it right here. And so then we have log of x minus 1 times log of x minus 1 is equal to, and for this expression here we take the product and we have the logarithm of that. And from the properties of logarithms, the log of the product is the sum of the logs. So then we can write log of 100 plus log of x minus 1. Now, since we're dealing with common log, which is base 10, the log of 100 is equal to log of 10 squared, which is just 2. So then we can rewrite this as the log of x minus 1, all of this squared, minus the log of x minus 1 coming from this term here, minus 2 is equal to 0. So rewriting, we have the log of x minus 1 and all of that squared minus the log of x minus 1 minus 2. Now, if we look closely, we can see that there is a quadratic expression hidden inside this equation here. And we can pull it out by doing a little bit of substitution. So let u be equal to log of x minus 1. So we did a little change of variables here. And if we do that, this expression then becomes equal to u squared minus u minus 2. And that's equal to 0. And from this quadratic, we can factor it. So this thing here is equal to u plus 1 times u minus 2. And we're setting this equal to 0, like we have up here for this quadratic. And so then either u is equal to negative 1 or u is equal to 2. So if we substitute this back into here, we have either log of x minus 1 equal to negative 1 or log of x minus 1 equal to 2. So let's look at the first case. We have log of x minus 1 is equal to negative 1. If we exponentiate both sides base 10, since it's a common log, then we get 10 raised to the log of x minus 1 is equal to 10 to the negative 1 power. Now, 10 to the log of x minus 1 is equal to x minus 1, based on cancellation properties involving function composition. And so we can write x minus 1 is equal to 10 to the minus 1, which is just 1/10. So this gives us x minus 1 is equal to 1/10. X is equal to 1 plus 1/10. And so then you have either 1 and 1/10 or 11/10, where this is our mixed number here. 1 and 1/10 is a mixed number. So in this first case, X is equal to 1 and 1/10, which is also equal to 11/10. For the second case, we have log of x minus 1 is equal to 2. And again, we exponentiate base 10. And so then we have 10 raised to the power of log of x minus 1 is equal to 10 raised to the power of 2. Now 10 to the log of x minus 1 just equals x minus 1, where we invoke the cancellation properties for function composition, in this case involving logarithms. And so then, as with the first case, we get x minus 1 is equal to 10 squared, which is also equal to 100. And so then x is equal to 100 plus 1, and this gives us x equal to 101. So we have two solutions. We have, in the first case, either x equal to 11/10 or x is equal to 101. And both of these solutions work in solving the equation at the top. And so we're done.